we want it to be the world's computer. Like we want to host every possible computation.
From EE Tech Media, this is Moore's Lobby, where engineers gather to talk all about circuits. I'm Daniel Bogdanoff. Building data centers is not easy, and building them well, that's a whole career in itself. Just ask today's guest, Marcus Fontoura, who's working on just that. Marcus is a technical fellow and corporate vice president at Microsoft. He's the chief architect in charge of Azure Compute, Microsoft's cloud computing platform, and leads the Azure efficiency team. He's faced with a particularly tough challenge. How do we make a data center more efficient? How do we do more with what we have? With the right architecture, could we even avoid building new data centers? This is a huge question, and the wrong answer is catastrophic. Fortunately, I don't have to figure that out, but Marcus does. Marcus, I'm excited for this. Thank you for being here today.
Me too. Great to be here.
How did you first get into computers, and what got you excited about engineering?
Yeah, I think I had my first computer. I was probably 10 or 11. It was an Apple II. Mainly I was playing games, but then got excited about programming. But somehow that went away in high school. And in high school, I became more like a math nerd. And then I thought that I was going to go to college for math and be a math teacher. But then when I started college, eventually I did computer engineering, but the first 2 years were common for math, physics, and engineering. So I thought I was going to do math, but then I took my first programming course, and then of course I loved it again, and I said I remember how much I loved it, and then from there on I decided to do computer engineering, which was like a mix of computer science classes and WE classes. So I had to do like a microprocessor lab that built like a keyboard or something and write the code for the hardware and all these things, which was interesting, of course.
It seems like a common theme throughout your career, balancing software and hardware. How do you balance being an expert in both areas?
I think this is more and more true. I think early in my career, I'm much more of a software distributed systems and large scale systems person. But I think like for the last 7 years of being in Azure, and then more and more like I got down to the nitty gritty of like the low level infrastructure powering Azure. So it became much more that like I need to understand like how the hardware works, how the DC works. I think this is like a recurring theme when I talk about this stuff. I'm a big believer that for the scale that we are, we need to really have a systems end-to-end view of things. So I think like core designing is a big deal for me. And then so working with computer architects and the hardware design, and DC design and software, I think is a big deal. And this is the way we get our competitive advantage.
What was the landscape of technology like when you graduated with your PhD in comp sci?
With a PhD in comp sci at that time, like I could be a university professor, but it's still like the big companies were not down there, like the research labs were not down there, and that's why I moved to the US. This was a long time ago. I think now it's landscape down there is a little bit different, and then you have like Microsoft, Google, a lot of the companies have presence there.
What technologies were popping off at that time? What was new and exciting, and what got you excited?
I think like Java was exciting, like the web was exciting, and search was exciting. Like so, a lot of my career working in search, and search was super exciting. Like I graduated my PhD in '99, so it's like early days of like Yahoo and Google, and I ended up working in both of these companies.
Yeah, so you've spent time at IBM Research, Yahoo, Google, Microsoft, and Bing, and now you're a tech fellow and vice president at Azure. You mentioned Codesign earlier. How do you define Codesign, and why is it so important?
Yeah, when I mentioned Codesign, I feel that computer will be much more pervasive going forward. Like the interfaces that we deal with, like, and of course, like the phone is an example, right? Like everybody has a phone, but like robots and like and everything we interact with. And then so it's not only a question of software, but a question of like interacting between software and hardware, and the ambient intelligence that permeates, like how to really understand like your intentions and also like actuate the intentions like with things that are in the space that around us that and be it like robots or like the apps on your phone or your computer or things on the cloud, right? So I feel that like to really make a difference and like do the science fiction work that we want to do, right? Like we really need to have like an integrated view between hardware and software. And I think this will be more and more true going forward, like as like computers are not something that are only in the data center, but they are everywhere around us.
You said a phrase that I don't think I've ever heard before. You said ambient intelligence. Can you expound on that?
Yeah, I think more like I think about intelligence. Like, of course, you know what you want to do, and this is your own intelligence. And then I feel more and more like the environment also will know what you want to do, and things will change around you by inferring things about your actions, your daily patterns, and then like what you do. Like, and we already see that this is true in many ways. For instance, when we drive a car, and then like my phone says like you normally go to this place or like to your parents' house on Monday nights, like so they already give me a map to go to my parents' house and the driving directions to get there, right? If you think about it, it's really surprising, right? Because it's really understanding your behaviors and making things easier for you. And then this intelligence that will not be invasive in a way like of like to be creepy, but in a way to make your life much easier. This is I think the nut that you need to crack, right? Like I think like we want computers to do something useful for humanity, and then like creating this understanding of society and behavior of people, and how can we use technology to make our lives better, right?
Can you give me some examples from your life where you've seen that element of co-design or ambient intelligence coming in and improving your life and making it better? Maybe just early examples.
Codesign you can see like in simple things, right? Like more futuristically thinking, like self-driving cars is something that like of course is a co-design, right? Like we don't have to drive the car, and then it's much safer for everybody. And then this is what like this is a combination of hardware and sensors and a lot of the software controls. So this is one thing that you have a major impact in society for sure. And then like and of course like very difficult ambient intelligence, like it's you have like the cloud, and that you can run like very large scale machine learning models, and that can understand like deep behavior, and this can aid in anything you want, like in your daily life, like providing, as I said before, like navigational instructions for you to go, and then like keeping your to-do list updated, your task list, calendar, and all that. So this is something that it's happening, and then I see in Microsoft, like we have HoloLens as a technology that are kind of an edge device, and the amazing applications that could enable that, like we could have a very complicated model of how to repair something in a factory, and that is not going to be printed. It will be projected for you, and you are inside the factory, and you can just say go forward, now turn left, turn right, screw this thing like 3 times and open this compartment, and then do your repair now. And suddenly like it's like Jetsons and science fiction, but like that's like what we are building, right? And I think we have a tremendous impact on society.
Oh, absolutely. How does hardware and software play together to achieve what you just described?
There are several levels. I'll talk like, for instance, in my daily work, I work on the infrastructure for the cloud. Like, so then I think what we are looking in there is like how to make all that computation possible, and how to run the hardware in the most efficient way we can run. And like, this is like both generic hardware and specialized hardware for like some types of compute. So the interplay there is like really understanding the hardware, like the types of computations we want to run, and the interface between the applications and the system's characteristics, both in terms of the hardware and what we have available in the data centers, like the amount of cooling you have, the amount of power you have. How hard can we drive some of these computations? This is something that is really important, not only for us, but for the planet and sustainability, right? So like we want to do all these great things that we want to do, but like the amount of power that we have in the world is limited, and we want to run these things in most efficient way that we can run. So in that sense, that is my daily work. Like there is a lot of interplay between hardware, software, and data center design, and really how we make things not only cheaper but also more sustainable.
So the benefits of being sustainable are pretty clear. What does being cheaper give you? Why is it important for you?
Cheaper is very important for me because like really what we want is to be able to democratize all this compute, right? So we want this to be something that anybody can use, like not only us in the US, but like third world countries, and we want, and the only way we're going to be successful there, enabling more and more people to have an online presence, is if you can make this thing cheap. And the only way to make it cheap is to work on these efficiency gains that we can do.
And then what does sustainability look like in the context of a data center?
Yeah, sustainability is really like something that is front and foremost for us, and a lot of the times it aligns that the most sustainable thing is also the most efficient thing. So like we are driving efficiency by running machines hotter, like using the power more efficiently and all that. That also drives sustainability, because the main goal for sustainability is to reduce the impact that we have by reducing the number of servers, right? To reduce the number of data centers. I always say like our most efficient data centers are the ones that we didn't build, right? We didn't build because we are running the ones we have like to the limit.
Let's take a quick break. We'll be right back with Marcus Fontoura. This podcast is sponsored by Allegro Microsystems, a leader in sensor and power ICs, and they're here to deliver you the semiconductor solutions that you need to create a safer, more autonomous future. Whether you're working on advanced steering and braking systems, heads-up displays, or cutting-edge autonomous driving systems, Allegro has a full suite of power and sensor ICs for your ADAS applications. With Allegro solutions, you're prepared to meet the challenges of tomorrow. Learn more at allegromicro.com. We're back with Marcus Fontoura. Marcus, if I mention Microsoft to someone like my parents, they're going to immediately think Windows, but it's certainly not accurate to lump everything into Windows. Can you paint the bigger picture for me?
Yeah, of course, like Windows is super important, right? But the way to view Microsoft is really to view Microsoft as empowering everybody to be more productive, empowering every person in the world to be more productive. And then to me, like I feel I contribute in both points. But first is this point of everybody, right? And this is the point that we just talked about. Like we want to try to democratize compute, make it cheap. So like I think there is a lot of work that Microsoft is doing as a whole, and then like in Azure we are super focused on efficiency and be it power, IT equipment, running it as hot as it can run, and managing the resources in the most efficient way we can run. There is a lot of innovation that we are doing in understanding workloads and how to best run these workloads in the data centers that we could have, or that we have today, right? So like we kind of coined this term of software-defined data centers, and it's a big, bold vision, but the vision is basically that like we had software-defined networks, that a lot of the programmability of the network now is done through software. We have the same vision for the data center, and then the data center is everything, like not the IT equipment that is there, all the critical infrastructure like the cooling and power systems and all the telemetry systems that we are running there with sensors to try to understand what's going on, and all the servers running the computation. So we want to monitor all that in real time. We want to understand the applications at a very deep level and understand what are the availability requirements, the scalability requirements of a given application, and then like use software to manage all that, which is a very complex problem.
Sounds incredibly complicated. What's the end goal? Where are you trying to get to?
Driving this vision of the software-defined data center is the way that we're really going to enable this democratization of compute, right? We want to run the cheapest compute that we possibly can so that we can empower everyone, right? So empowering everyone. Then the second part of Microsoft vision is to make it everyone more productive, and more productive is like all the applications that we can run in this compute that we are democratizing. And if you get to that point, then I think all this work that we are doing in AI, and then this idea that I talked about, ambient intelligence, that we want to have like very complex models running in the cloud, but you want to have inference running in the edge, and to have this connectivity between cloud and edge with different devices like HoloLens, robots, and whatnot, your phone. How can we use this infra that we are building to make people more productive? Where I think really in the early days here, like of the types of applications that this will unlock, but I think the sky is the limit here. Like I think there is a lot of potential for us.
How would you describe a software-defined data center?
Is a data center that functions like in a completely automated way, right? You can make even the parallel to the self-driving car, right? So what is a self-driving car? You have a goal that it's to get somewhere, and the car will drive itself, like using software to control it with sensors and whatnot, right? So in the software-defined data center, we can draw the same parallel, that like we have lots of sensors, we have all the IT equipment that is the hardware and the servers that we are running, and then we have all the electrical infrastructure, and then we have like the workloads that are ultimately running there, right? So like basically the whole goal, we just have all this infra because we want to run the workloads. So the whole goal here is to run the workloads in the most efficient way, most cost effective way to run these workloads, and respecting their like requirements in terms of availability and whatnot, right? Which is like comes to the first question is like, how do you understand workloads, right? So like, because for Azure, like we are running virtual machines. Like, so basically, if you look at Azure in a black box, you have virtual machines that are running third-party applications. So I kind of don't know what is running in this virtual machine. So I need to have a deep knowledge so that, and the more I know, I can run it in a more optimized way, right?
So what you're saying is you have third-party applications running on your virtual machines. You don't necessarily know what those applications are, but you have to still optimize for what they're doing.
Yeah, exactly. The reason I can do this, and this is was again like key innovation that like Microsoft is on the edge here, is like using a lot of the machine learning that we have in-house for systems and for trying to understand workloads, right? So it turns out that we have a scale and that is large enough that enables us to run predictions and understand like how these applications behave, even though they are a black box for us, right? But we can predict how much CPU they're going to use, how much memory they're going to use, what is the likelihood that they are user facing or not, how long they will live, like and like just to bring this to a very concrete example, right? So like, for instance, if you can predict how long an application will live, like that is running in a virtual machine, and then I need to do a maintenance action on a server that is running on my data center because I predicted that like maybe the disk is going to fail, right? So now I have a decision, right? What do I do with this virtual machine? Having some notion if it's going to last 3 more seconds running like some computation of a function, or 3 more months because it's a long running process, makes a lot of difference in the actions that I'm going to drive for the repair of that server. Using intelligence to understand like these black box applications that are running in my data center is like a fundamental piece, right? So like the workload understanding is one side, then the other side is like having all the bells and whistles and controls, like sensors and things like that on the physical side, and then having the software policies and intelligence and all that like we want to that will drive us to the goal state that we want to get. Like the same way the self-driving car will get you to a destination. My destination is keep everything running at the minimum cost possible, at the minimum carbon footprint possible, and respecting all the requirements of every possible application that's running in the data centers.
So make it cheaper and more efficient, but everything still has to work. Sounds complicated. One thing I noticed was you are both a vice president and a technical fellow. What does that look like for you, and what sort of teams do you work with?
Normally, like the technical fellow distinction is given to people who have a technical career, and vice president distinction is given to people who manage large teams, and I happen to do both. There is a few others in Microsoft and of the technical fellows that also have large teams, and this is not that uncommon now. I juggle both. Like I still am deeply involved in the technical direction and working across Microsoft with people from other divisions and like what are the requirements for Azure and trying to understand like so like all the first parties that use Azure and managing that aspect of it. And my team is largely focused on implementing this vision of software defined data centers, right? Like, and how can we drive it? So I have both a large team that I manage in my day to day, and also like I'm involved in a lot of technical discussions across the company and outside the company.
What types of teams do you have? What are people working on?
It's like multi functional. Like I have both like software engineers, I have like hardware architects, I have data center people, I have data scientists and machine learning people. So like these are the main functions. Maybe you already guessed why I have people from all these functions, because like we talked about a lot about this vision of co-design and doing things together, and I think like it's a huge advantage for me as Microsoft, right? Because I know I have the hardware that I'm managing in my data centers, and now I know how I'm going to manage the hardware in terms of repairs and like how hard I'm going to drive it, what is the potential utilization and all that. I can really tailor my software to take the most out of the hardware. And the data science and data engineering is a key part of it, right? Like both for the hardware management side, like that we want to have like predictions about everything that's going on the data center, but also on the workload side, because as I said, like these things are mostly on black box for me, and I have to have understanding. So we have a lot we do is based on predictions.
Well, I have a prediction for you. We'll be back in about 30 seconds. This podcast is sponsored by Allegro Microsystems. Allegro Microsystems is developing intelligent solutions that move the world towards a safer and more sustainable future. Their ASIL-rated devices offer the latest, most advanced technology and algorithms. They are built with flexibility in mind to ensure that your designs are ready for the future. In an ever-changing landscape, Allegro Microsystems is ready to partner with you to drive your innovative automotive designs forward with safety in mind. To learn more, visit allegromicro.com. We're back with Marcus Fontoura from Microsoft. Marcus, you said earlier that the most efficient data center is the one you never have to build. I'm curious, when you're right on the brink of capacity and maybe wishing you had another data center to work with, do you get nervous or do you get excited?
I get excited. No, truly. And then like COVID put us to the test, and not only us, but probably I'm guessing every cloud provider out there. What happened during COVID is like when we went into lockdown, the world became online from day to night. And of course, like I'm serving first responders, I'm serving schools that are now switching everything online, like office workers that are completely online at that point. And that was coupled with like a supply chain crisis. So even if I could buy servers, I couldn't physically deploy servers in the data centers. And this became a very challenging couple months that we had to manage the capacity. But for me, it was super exciting because this was putting to the test everything that I'm talking to you about, right? We really have like this deep knowledge of like the workloads that we are running on Azure. We know how to manage. We know how to manage power efficiently. We simply saw like a multi-fold increase on the utilization of the Teams service, with like all the schools becoming online and everybody working from home. But we cope it brilliantly, and it's really like it was one of my proudest moments, like when we hit like, that capacity crisis like during COVID, because like I felt that I was preparing for it, and then because I knew it was eventually going to happen, and it did happen. Unfortunately, I'm not saying that I'm glad for COVID, but I'm glad that like we sustained it.
So you're almost the Azure first responder. Was everybody calling you like, "Hey, I'm at capacity, help"?
Not only me, but a lot of it was like a group effort with a lot of people across the company. Even the executive vice president, like we had like a call like 7 days a week. It was a great collaborative effort across the company, because as you probably can guess, like a lot of our first party services also run in Azure, and Microsoft is a service company, so you would think like that almost leadership from the entire company were in these calls, and things simply work, right? So it was a lot
Yeah.
of very detailed work from the capacity teams and from us and from all the first parties, but was fun.
Very much a trial by fire then. Do you have any stories you can share from maybe those first 6 months as everyone was scrambling to keep things online?
I wish I could show you some graphs, but like one of the things that was fun for me is to see like the WAN graph, the wide area network graphs that we had, like the traffic in some of the links that really spiked up after the lockdown. So I was like trying to maintain and operate the links and even operate the WAN and how to handle the WAN capacity. Also, like it was a great job from the networking team. So it was across the board, like a lot of fun and exciting moments.
What has been most exciting about taking on this challenge? I imagine you get to pull in a lot more different expertise than you typically would when spinning up a data center.
Given my history, that I was mainly a software person, distributed systems and all that, like of course I always worked in efficiency, because like that's what we do in large scale distributed systems. But now that we are like, and you talk about Microsoft being an OS company, almost I feel my team is like the cloud OS company, cloud OS component, right? Because like we are basically providing the building blocks for managing all the resources in the data center, and exposing the compute, right? So like that's exactly what an OS does. So if you think like this vision of a data center as a computer, we are kind of the OS for the computer. And in that vision, I think it's a lot more cross-disciplinary than I was used to, right? Of course, like data scientists and data engineering was always present in my life, but now I think I'm working more with the mechanical engineers, electrical engineers, and across the board, like in a lot of the initiatives, and a lot of the areas were new to me. Like when I started working with power management, I had to learn a whole bunch. So I love learning. So it's been like incredible ride in that sense.
What have you been working on with your mechanical and electrical engineers? What sort of projects or initiatives?
Like for instance, like one of the key things that we are doing now is like working on liquid immersion cooling. We want to make like cooling a known issue, and probably you saw in the news like that Microsoft was like the first public cloud to announce that we had like production racks using liquid immersion cooling, and then like just in the designs of the tanks, and how can we co-design the tank, and what are the software controls, and what are the failure domains of like these liquid immersion tanks. This is like quite incredible to put those things into production.
So is liquid cooling a big step forward for the industry, and what advantages does that give you?
Yeah, I do think that we are really pushing the boundaries there. Like liquid immersion, like buys us a lot of things. One of the most immediate things is like the cooling capacity. Like we have much more ability to cool, which is really important for us with the more and more hot, power hungry components that we have to cool in the data center, right? So we knew we had to do something there, right? So like just having to look around the corner and do something before this becomes a real problem, like we started investing there, and then but then there is a lot more opportunities that that cooling capacity gives us. For instance, like one of the ability to overclock CPUs, for instance, and when to use this overclocking, right? Where like it's interesting because like suddenly like if I need to spike my servers like at a given time because I have a whole bunch of batch computations happening, or like a large ML model, if I have a lot more cooling capacity and I have that ability, then I can do so, right? So like this is only possible because, again, right, like I have like a software brain that is the software-defined data center manager that really understands not only how much power I'm consuming, how much cooling capacity I'm consuming, what are the demands of the workload, and how to best use that power and cooling capacity that I have at a given time, like multiplexing the applications that are running at that moment, right? So that just co-designing that together with designing like the physical tanks and the hardware that go inside the tanks and which fluid we are using for the tanks. Like all that has been a lot of fun.
So you can almost go over capacity if you can overclock. Like if you get really hit with it and you can cool it down, you just overclock and you're maybe over 100%.
We can run over 100% for certain periods of time. There are scenarios that we want to do that.
Like you mentioned, like large ML models, that sort of thing, or are there any other scenarios?
Yeah, either that, like, or even if you think about a much simpler scenario, like the team service, every time that it's the hour or half an hour, there is a lot of meetings starting. So CPUs spike, and then they come down as after everybody joins. Like, so I think we could use extra capacity at given points that are very limited in duration.
So if my team's meeting's crashing, I know who to blame. Are you redesigning existing data centers or architecting new data centers as they get built?
Both. I think we're doing both. Like we're really pushing the envelope there in all fronts. Like not only me. Like of course I'm not a data center designer. I work with our design team, and we are looking to data center design for several reasons, right? Like one, we have to be very innovative in terms of like making our designs more and more sustainable over time, right? So like for instance, like we believe that liquid immersion cooling will give us a big boost in sustainability, in our water less commitments, like all that, right? So we are really doing all that we can do, and in every geo that we go to, we want to see like what are the power sources and like make it the most green that we can make.
I heard one of your redesigns saved like 150 megawatts of power, which is like 4 or 5 data centers. That's pretty incredible. How do you do that?
What we did is just doing better power management and reducing power stranding across the board in all our data centers by just doing better packing of like servers in certain regions of the data center. Once we can control through software the trade-off of availability of the workloads and availability of power, right? So like I think like if you can have like this very simple mental model that like the easiest thing to do is to over provision power. But over provisioning power is very expensive because power is a very scarce resource, and we want to use all the power we can use. On the other hand, like if you use all the power to the limit, you are risking tripping breakers and things of that nature because like workloads can burst and all that. Once you have like a very fine-grained software control that we can control the trade-off of availability of the workloads and the amount of power that you have in real time, then we can do a much better job, and then we can save a ton of power, right? So like saving a ton of power, as I said, like our most sustainable data centers are the ones we didn't build. Like in that case, if we did save like 150 megawatts of power, this is like 5 data centers of 30 megawatts that we didn't build. It's a huge impact on the planet.
You mentioned the term power stranding. Can you explain what power stranding is for me?
Like we get a certain amount of power from the utility. Like let's say like we build a building, we're gonna put a lot of IT equipment inside that building, and that we might say this utility is for like we have 32 megawatts of utility power, for instance, for that building. If you don't use the full 32 megawatts that you provision your power delivery infrastructure to do, like then you are stranding power, right? Because you have the capacity to consume all 32 megawatts, right? So the best thing that you can do is to use it fully, right? Like, and even the best thing for sustainability, and this is something that I'm a big advocate for, right? So it doesn't even matter if it's a green energy or not. Like once you provision and you deployed all that heavy equipment there and you build the building, the best thing that you can do to the world is use to the max, right? And the same thing is the servers. What you want to do for sustainability is the best thing you can do is run the servers at the maximum utilization that you can run. That wouldn't violate the requirements of your application, right? So you don't want to run to the point that applications are not behaving well anymore, but given the limit, you want to run it to the limit because like the less servers you buy, you have the most impact. The less data centers you build, you have the most impact.
So less is more here. So far, we've talked a lot about data center strategies, But I'd like to take it up another layer. What's the goal of Azure? Where do you want all this to end up?
So Azure is the world's computer, and that's how I view it, right? Like, we want it to be the world's computer. Like, think about it, like, it's just a service that we provide, that we want to host every possible computation, like, be it large scale machine learning models, be it like a stock management system, or like a simple database application, or whatnot, right? So we want to host it all in the most efficient way possible. So it's so fundamental that we do a great job in resource management and in all these ideas of like running things to the fullest potential, because I feel Azure is a win-win-win proposition, right? Like, it's cheaper for people to run their workloads in Azure. It's good for us that we are providing a great service, we as Microsoft, and it's good for the world because we would do a much better job than like every organization like that out there trying to maintain servers, maintain cooling, maintain power, maintain the availability of their applications. So that's how I view it.
Okay, so if you're able to do it more efficiently than everyone else, you can match their performance but at a lower cost for everybody. I imagine this is evolving tech. How has the architecture changed over the years, and how will it change in the future?
I mean, tremendously, right? So, like, I think, like, for instance, like, just this idea of liquid immersion is like opened so many doors, like, and even new avenues that we didn't think in the past, because even failure rates of components are very different, for instance, and then now we might design a repair strategy for servers that are much different than before, when servers were failing more. So I think this is a very gradual evolution. Sometimes we have like step changes, but we are always trying to evolve like our management system. The more we gain understanding about how people are using the infra, and that's a key thing, right? I think data and the insights of using data and in doing this like data-driven approach of understanding the applications and optimizing for the applications. A lot of people think about like, what is the availability of your infrastructure? Like, oh, is this data center like 3 nines of availability, 5 nines of availability? The way I think it's very different. I think about, for me, who has availability is the application. What are the availability requirements of the application? How much outage that application can tolerate? Like, what are the mechanisms that we manage that application in case of like having like a power outage in a given region? What are the failover mechanisms and all that? So the more we understand the application, then we can decide what's the best way to deploy that application in our data center, and you give the right amount of availability for every application in the world, right? So that's way we are viewing it, and the more we understand about the applications and the more understanding we have about our own infra, and then we can manage it in a more tight way, we are going to do a better job. Like, and this understanding of our own infra is, for instance, even very hard things like predicting when disks are going to fail, predicting outages, really understanding what are the failure patterns that occur on large scale, and managing those in the most efficient way we can.
Well, I predict that it's time for a quick break. We'll be right back. This podcast is sponsored by Allegro Microsystems. Automotive passengers, more than ever before, need to have confidence in the electronic componentry driving their cars. Allegro Microsystems is here to help you meet the stringent requirements of safety-critical automotive applications with their power and sensing solutions. Their extensive automotive solutions, gate drivers, current and position sensor ICs, lighting, and more cover your ADAS needs and help give your passengers the confidence they need in their cars. Learn more by visiting allegromicro.com. And we're back with Marcus Fontoura. Marcus, a couple industries that I've seen rapidly investing in cloud computing are automotive and industrial automation. What sort of future for cloud compute do you see in these spaces?
Yeah, I think like one key thing there is like this idea that I talked about, the edge computing and the combination between the edge and the cloud. And I think like our vision on edge is very pronounced and maybe even a little bit different than other cloud providers, because like we thought about edge from the beginning, and we thought that this idea of ambient intelligence and edge and cloud, this is like the killer combination for us, right? So like I think like thinking that like you can have people on the factory floor with like a device that is an edge device that is showing things real time, and these things can be derived from like very large computations that are running in the cloud, and then so this is like where I think there is a lot of potential for gains, and not only people on the factory floor, but like robots and everything automated in the most efficient way possible. I think this is really a beautiful vision, right? That like this combination of edge and cloud, I think it's unheard of, right? Like this is what we are living now, and then I think maybe for like people that are just born now, like this is the norm. But I think this is just a revolution, like from what it used to be, and it will continue to be more and more revolutionary as we go forward.
Where do you see the balance of edge computing and cloud computing and how they play together?
I think it needs to be an organic balance, right? So I think, of course, like the cloud, what goes in the edge, what would aid you to do the tasks that you need to do in the edge as you move around in the world, and everything else goes in the cloud. And then the advantage of the cloud is that we have like more machines, we can run more powerful computations and all that. And since you have good connectivity, this can be very seamless, like the integration between edge and cloud. So I think this is again an area that I think there will be a lot of innovation in terms of business and application and models, but I think might happen organically as people use like these edge devices like in their daily lives.
As we get near the end of every episode, I like to do a lightning round. So question number 1, what are the top skill sets you would tell an early or mid-career engineer they should really focus on if they want to be successful down the road?
Yeah, this is really a great question. Like I feel that everybody says like software is a great skill set to have because everything will be software. One of the things that worries me now is that people use very high level software programming languages, which is great because they can code anything very quickly. But then we don't have the connection to the actual hardware and how things actually work. And I think for me, a killer combination of skill sets is like computer architecture, software, and also stats, ML, data kind of thing. Because, like intelligence will be like key for us, like driving insights and using machine learning for predictions. This will be like, we cannot do anything at large scale if we don't use intelligence. Software, we need to codify these things in an automated way and drive automation if you want to do anything at scale. And hardware, because I think it will be much more pervasive going forward.
You mentioned earlier that your first computer was an Apple II and you did a lot of gaming. What's your favorite or most nostalgic Apple II game?
I like the Space Invaders. I'm not even sure that was Apple II, but like the one that I remember like is like this like retro version of Space Invaders and Pac-Man. These are my nostalgic games.
Awesome. Sounds like you might have had an Atari as well.
I had an Atari. Like this was not even Apple II.
Awesome. What Brazilian food would you recommend that somebody try?
There is something that I really like that's called cheese bread. It's like in Portuguese pão de queijo. Is like and I think we can get even in a lot of the supermarkets. And I know that Costco sells it, and you can bake it, and it's really delicious. And everybody like it's very common in like birthday parties and things like that in Brazil.
Well, I like cheese and I like bread, so that sounds like a winning combination.
Yeah,
Marcus, thank you so much for being here today. This was a blast.
Yeah, thank you. I'm very happy to be here. I had a lot of fun talking to you about these things. I get very excited because I'm really passionate about this area.
Well, we can tell. It's been great having you. That was Marcus Fontoura, Microsoft VP and Fellow. Thanks everybody for joining me today in the lobby. If you liked this podcast, make sure you're subscribed in your favorite podcast tool, and also go to the Moore's Lobby social pages and tag or mention someone that you think will like this podcast. We're sending out Moore's Lobby swag to folks that do. I make myself a pour over coffee in my Moore's Lobby mug every morning. It's blue, but not quite like Azure blue. I'm your host, Daniel Bogdanoff. I'll catch you next time.